So we're doing problem 17.44. And in this one, what we're given is we have 0.29 kilograms of water at 18 degrees Celsius. And we're trying to find the amount of energy it takes to freeze it into ice. And so to do that, we're going to start using this equation here. We have Q, which is our heat, it's our energy, equals the mass of the water, times the specific heat of the water, times the change in temperature. And our specific heat of the water is this value. It's 4,190 joules per kilogram times degrees Celsius. So we're going to plug this in here. And we get our Q equals 0.29 kilograms times 4,190 joules per kilogram times degrees Celsius times our final temperature is 0 degrees Celsius minus 18 degrees Celsius. And if you plug all these numbers in, you get that our Q is negative 0.2187 times 10 to the negative fifth joules. And it's negative because the energy is leaving the system. Now we need to factor in the state change. We need to see how much energy it takes to change the water into ice. And so for this, we're going to use Q equals mL of water. And L is what we call our heat of fusion of water. And that's this value right here. So plugging those in, get Q equals 0.29 kilograms times 3.34 times 10 to the fifth joules per kilogram. And what we get is this comes out to negative 0.9686 times 10 to the fifth joules. And right here, this should also be 10 to the fifth, I believe. And so we're going to add these two together now to get our net heat. And so what we're going to find is that our net is 1.1879 times 10 to the fifth joules. And they're no longer negatives because we're just looking at the total value, not the direction in which it's moving. And so now we just need to convert that to calories and BTUs. And so to convert that to calories, we're going to take that number, 1.1879 times 10 to the fifth, and we're going to divide it by 4.186, and then we're going to multiply it times 1,000. And what we end up getting is 28.4 kilocalories, or capital C calories. And then we also need to convert it to BTUs. So we're going to take the same number, 1.1879 times 10 to the fifth, and we're going to divide that by 1,055, and that's going to give us 113 BTUs. That's it.